Mr. Picard here, bringing you another dose of geometry. Today we're talking about the application of the Pythagorean theorem and its converse. Let's just review real quick. What is the Pythagorean theorem? The Pythagorean theorem says that in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. We generally state this in an equation, and that equation is a squared plus b squared equals c squared, where c is the length of the hypotenuse and a and b are the lengths of the legs. Converse of the Pythagorean theorem says that if the square of the length of one side of a triangle is equal to the sum of the squares of the lengths of the other sides, then the triangle is a right triangle. So we basically run that in reverse. How do we apply these two rules? In a prior lesson, we looked briefly at this idea that we can use the Pythagorean theorem and the converse of the Pythagorean theorem to determine, by looking at the sides of a triangle, whether the triangle is in fact a right triangle. We'll extend that just slightly now. Let's look at obtuse and acute angles in triangles and see if we can sort of connect the obtuse and acute angles with the Pythagorean theorem. First rule we'll look at here is called the obtuse triangle theorem. It says if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. What does that look like? Here we have a triangle, and you can see that the lengths of the three sides are all identified. We have a side that is 11 units long, a side that is 6 units long, and a side that is 9 units long. I think we can agree that if this were a right triangle, we would all anticipate that the 11 is the hypotenuse. Now, I'm not saying it's a right triangle. I'm simply saying that if it were, we would look to the 11 to be the hypotenuse because it's the longest side. When we look at the obtuse triangle theorem, we simply find the squares of all these values and we ask the question whether it's a right triangle, and more particularly whether this angle down here is either 90 or is it obtuse. Here's how we do that. The first thing we'll do is square the 11, and 11 squared is equal to 121. So we already know this much, that if this is a right triangle, then the sum of the square of 9 and the square of 6 will be 121. Let's check that out. So we square the 9, which you know is equal to 81. And we'll square the 6, which is 36. And then we'll add the 81 plus the 36. And what do we get? 81 plus 36 is 117. In other words, the sum of the squares of the legs is not equal to the square of the longest side. Therefore, we can be certain that this is not a right triangle. So, can we figure out anything more? Can we say anything about this angle down here? The answer is yes. If the square of the longest side were 117, then it would be a right triangle. But this longest side is longer than that, which means this must be an obtuse angle. In other words, because it's not 117, but rather 121, it's a longer number, it means that angle has to be greater than 90 degrees, and therefore it's obtuse. The next rule we have is called the acute triangle theorem. It says if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, the triangle is acute. So here we have another example. You can see the sides are 9, 12, and 14. And one of the questions we have is this a right triangle? And if it's not, is it acute or is it obtuse? We start the same way. We simply square the sides. So 14 squared is equal to 196. 12 squared is equal to 144, and 9 squared is equal to 81. The next step is to add the squares of the two shorter sides. So we have 144 plus 81, 225. And so we ask the question, how does 225 compare to 196? We know that if this were a right triangle, the square of this longest side would be 225. But in fact, the square of that longest side is shorter than that, which means that this 14 is shorter than what would be the equivalent of a hypotenuse in a right triangle. What does that mean about this angle? It means this angle must be acute. It must be less than 90 degrees. So we find that if the square of the third side is shorter than the sum of the squares of the legs, then we're dealing with an acute triangle. And of course, remember, if we're dealing with a situation where the square of the longest side is equal to the sum of the squares of the two shorter sides, then we're dealing with a right triangle. Let's look at one more application before we wrap it up. This is a picture of a foundation being put in. You can see the workers have laid forms into the ground here. And the next thing they'll need to do is to pour concrete into the forms in order to establish the foundation. In fact, if you look back here in the upper right corner, it seems they've already begun to pour some concrete in there. At least it appears that way. Either way, they will fill these forms with concrete in order to build the foundation. Now, one of the things they want to do before they actually pour the concrete is they want to make sure that the forms are set correctly, that is, that the angles are correct. So, for instance, one of the things they probably want to check is whether this angle in here is in fact a right angle. How do they do that? This is a very common trick on the job site. It's something that most carpenters, framers, construction personnel know how to do. And one of the easiest ways is to do this. They'll measure up along one side here a known distance, for instance, 3 feet. 3 feet is probably one of the more common distances. And they'll make a mark on the wood there. They'll measure up this side 4 feet, and they'll make a mark on the wood over here. Then they'll take their tape measure and they'll measure from one mark to the other like this. And they should find that it's 5 feet. Why 5 feet? Because if this is 3 feet, and this is 4 feet, and it is in fact a right angle, then they should find that the hypotenuse is 5 feet. They typically use Pythagorean triples, 3, 4, 5. Or maybe they'll use 6, 8, and 10, depending on exactly where they're measuring and how convenient that is. So what happens if it turns out that when they measure the 5 feet, that longest side, what happens if it's actually 4 feet 10 inches? Well, they know that they have an acute angle and they need to bring this side or this side down a little bit. They need to open the angle up a little more to get to the 5 feet. What happens if they measure it and it's 5 feet 2 inches? Well, that means they have an obtuse angle, and in that case they need to bring one of the sides in. And so they'll use these measurements, and in particular the Pythagorean triples, to ensure that the corner is actually meeting at a 90-degree angle. That's one very common application of the Pythagorean theorem, its converse, and more particularly the obtuse triangle theorem and the acute triangle theorem. As always, make sure you work through a few review problems. If you have any questions, feel free to send me an email.